And so what I'm trying to show here is if you know their masses and their initial velocities at the beginning, which we do, and you know their masses after the collision stay the same, and you know the angles at which they part, you can actually use the law of conservation of momentum to solve for both of these unknown velocities. And the way we're going to do that is we're going to use two equations that we have. So basically, we have this, that the momentum in the x direction initially, so I'm going to use pxi. P stands for momentum. X means we're talking about the x direction, which is the horizontal direction, left and right on my board. And the I stands for initial, which means before the crash, should equal the momentum in the x direction. And I'm going to write F for final, which represents after the crash. So this equation simply says the total momentum of my two balls added together in the x direction, horizontal, before the crash should also equal their total combined momentum in the x direction after the crash. And so that is what we're going to call equation 1. The other equation that we have to work with is the momentum in the y direction initially should also equal the momentum in the y direction finally. So total momentum in the vertical up and down direction before these two objects collide together should equal the total momentum vertically in the y direction after they collide. So because we have two available equations to solve, we are capable of solving for two possible unknowns. And it just happens to turn out in this problem, I'm giving you two unknowns, velocity of this ball and velocity of this ball. Now, if I also asked you to solve for an unknown angle, we would not be able to do that because we have two unknown velocities and an unknown angle. That's three unknowns, but we only have two equations. So the maximum number of unknowns we can solve for is 2.